For this lesson, we're going to be talking about the mole. So understand that a mole is just a way that we count atoms. So first we're going to talk about other words that represent numbers. Okay, so for example, you probably all know these different types of terms, but how many shoes are in a pair? We would have 2 shoes for 1 pair. Okay, how many eggs are in a dozen? We know that a dozen means 12, so 12 eggs. Okay, so using these words, we can also kind of do math equations as well. So for question 3, how many shoes would you have if you had 5 pairs of shoes? So if I have 5 pairs of shoes, and I know that for every pair I have 2 shoes, I can multiply that together to get 10 shoes for my 5 pairs. Okay, same thing for number 4. How many eggs would be in 3 dozen? So if I have 3 dozen and I know that there are 12 eggs in a dozen, I can multiply it to get 36 eggs. So for the read this, I have the equation 2H2 plus O2 yields 2H2O. So this chemical equation states that you need 2 molecules of H2 to react with 1 molecule of O2 to produce 2 molecules of H2O. So isolating a single molecule is practically impossible. So we have to scale up the numbers of the molecules using the mole. Okay, so we can't just do a reaction using 2 molecules and a single molecule. It's just too tiny of a reaction for us to even see. Okay, so we use this mole to scale it up. So just like the word dozen means 12, the word mole means 6.022 times 10 to the 23rd. This is a number that you're going to have to memorize, okay, but we'll be using it quite often in this chapter, so you'll learn it over time. This number is known as Avogadro's number. Okay, so here we have Model 1, counting eggs and atoms. So for question 5, it says in Model 1, determine the mass of each quantity of eggs, and then how did you calculate it? Okay, so if we know that 1 egg has a mass of 37.44 grams, okay, if I have 10 eggs, I would just multiply 10 eggs times the mass of a single egg to find the mass of all 10 eggs. Okay, same thing with the dozen. I would take 12 times my mass of a single egg to find the mass of all 12 eggs. Okay, and then same thing with a million. I would take 1 million times my mass of a single egg to find the mass of the million eggs. Okay, I'm not going to go through and do all that math with you guys because that's pretty simple calculations. Just make sure you go through that. Okay, and I kind of explained how we calculated it. We just multiplied the quantity by the mass of a single egg. Okay, for number 6, it says in Model 1, calculate the number of atoms for each molar quantity of gold. Okay, and how did you calculate it? So over here we have our atoms, moles, and mass of gold. Okay, so it says for 1 mole, we have the 6.022 times 10 to the 23rd, so Avogadro's number. Okay, anytime we see 1 mole, we know that it's this number of atoms. Okay, so if I have 2 moles, I'm just going to multiply this number by 2. Okay, I am going to show you how you put this into a calculator on your phone. If you have an iPhone, if you turn it on your side, you'll get this screen. Okay, and so how we would put it in, we would take the Avogadro's number, so 6.022. To do the times 10, you're going to hit the EE and then our times 10 to the 23rd. Okay, so that gives us Avogadro's number. So 6.022, the E stands for times 10 to the 23rd, and we're going to multiply that by 2 in order to figure out how many atoms are in 2 moles of gold. Okay, so then I would write this, or I would just round this to 1.2, and then the E means times 10 to the 24th. Okay, and then same thing for 3 moles. I would just take this original number, Avogadro's number, times 3 in order to determine how many atoms. Again, I'm not going to go through and calculate all of them. So in order to calculate it, we just multiplied the number of moles times how many atoms are in 1 mole. Okay, for number 7, it says calculate the mass for each molar quantity of gold, and then how did we calculate it? Okay, so it tells us that 1 mole of gold has a mass of 196.97 grams. Okay, so in order to determine the mass of 2 moles, we would just take this mass times the 2. Okay, and then for the 3 moles of gold, we would take this mass times 3 to find how the mass of 3 moles of gold. Okay, so again, how did we calculate it? We just took the number of moles times the mass of 1 mole of gold. Okay, so for number 8, if you had 7.2264 times 10 to the 24th atoms of gold, how many moles of gold would that be? And then how did we calculate it and show your work? Okay, so if we know that 1 mole of gold has this many atoms, okay, and we're given a total number of atoms, we can divide in order to determine how many moles that is. So we can take our 7.2264 times 10 to the 24th divided by Avogadro's number. So 6.022 times 10 to the 23rd. Okay, and so when I put this in my calculator, and I'll go ahead and do that with you just so you can see it again on the calculator. So 7.2264 times 10, so EE to the 24th, divided by Avogadro's number, so 6.022 times 10, so the EE button to the 23rd, is equal to 12. So we have 12 moles of gold. Okay, for question 9, using your answer from question 8, determine the mass of our 7.2264 times 10 to the 24th atoms of gold in grams. Okay, so we already converted it to moles, and so then we can easily go from moles to mass. Okay, so we can take our number of moles of gold times the mass of a single mole of gold in order to determine the total mass. So we would take 12 times our 196.97. So 12 moles of gold would have a mass of 2,364 grams. Okay, for question 10, what do you notice about the mass given for 1 mole of gold in Model 1 and the reported mass of gold on the periodic table? So we see here that the mass of gold is 196.97 grams. And if we go look at the periodic table, okay, we can also see, so AU, which is element number 79, also has the mass of 196.97. Okay, so they get that mass of 1 mole of an atom or of an element from the periodic table. Okay, so the mass of 1 mole of any pure substance, an atom or compound, is called the molar mass. So molar mass has units of grams per mole. Okay, so sometimes they'll be asking for the molar mass, and that's just the mass of 1 mole. Okay, but if you have more than 1 mole, it's just asking for the mass of the substance. So we would just use the unit grams. So for atoms, the molar mass is numerically equal to the atomic mass of the element on the periodic table. So just like we saw with gold having that mass, it's exactly equal. If we have 1 mole of gold, it's going to be equal to whatever the mass is on the periodic table. And then, for example, the molar mass of lithium is 6.94 grams per mole. And if we look at the periodic table, okay, we see lithium over here. Okay, the mass of 1 mole of lithium is 6.94 grams per mole. Okay, so for number 11, we're going to determine the molar mass of each of the following. So we have aluminum, potassium, oxygen, and hydrogen. Okay, so for aluminum is here. It's going to have a molar mass of 26.982 grams per mole. Potassium, which is here, is going to have a molar mass of 39.098 grams per mole. Oxygen, which is found here, is going to have a mass of 15.999 grams per mole. And then hydrogen, which is here, is going to have a molar mass of 1.008 grams per mole, which just means for every 1 mole, it has a mass of 1.008 grams. Okay, so question 12, what would be the mass of 1 mole of helium? So if we go back, helium has a mass of 4.0026 if we only have 1 mole. In this case, we have 1 mole. Notice that they're asking for the mass, not the molar mass. So they're asking the mass of 1 mole of helium. So we're going to have 4.0026 grams. Okay, and then for question 13, it says what would be the mass of 3.5 moles of helium? Okay, so if we know that 1 mole equals this, I can take the 3.5 times this mass in order to determine the mass of 3.5 moles of helium. So 3.5 times our 4.0026 is going to give us 14.0091 grams.